Hi, I'm Sophie Koala, MPP for Kingston and the Islands, and we're here taping another episode of Conversations with Sophie. I am here with Doug Wilton from TECTA-PDS, and we will be focusing on the wonderful innovation that TECTA-PDS is bringing forward to Ontario. One of the reasons, I just want to elaborate a little bit on one of the reasons why I do this show. It's because Kingston is a city that has a motto of where history and innovation thrive. This is really important. It's wonderful for our riding and for the province in general, but we need to make sure that we do everything possible to boast about our local companies that we have in Kingston and the Islands, and we've got a lot to boast about. So without further ado, I'd like to introduce to you Doug Wilton of TECTA-PDS. Doug, thank you for being here with us today.
Thanks so very much, Sophie. We're really thrilled that you're joining us today, and thanks so very much.
Thank you, and I'm wondering if you can tell our audience a little bit about your mission statement.
I'd love to. Here at TECTA-PDS, our goal is really to revolutionize the monitoring of drinking water for microbiology, specifically for E. coli and total coliforms. Those were the bacteria that were deadly and caused the Walkerton crisis in the early 2000s. And that was really the reason that this company was formed, because the systems that were out there that were in place, they failed, and they failed the people of Ontario. And we wanted to create a system that would be far, far superior. And that's what we've done. We're selling it to the world. And starting off in 2003, as I said, in the wake of the Walkerton disaster, I joined the company in 2005. At that time, we doubled in size because we went from 1 employee to 2. So 2 employees in 2005. And absolutely, we were into Queen's University. Queen's has been a great partner to have from the beginning. They continue to be a good partner today. And we continued on, and we attracted the attention of the world's largest water company. They're a French company by the name of Veolia. And Veolia bought the company in 2009. And in 2009, we became a new name, Endotech, and we were part of the monitoring platform for this global company that was based in France. And you're right, during that time, both the Ontario government and the federal government were very helpful for funding. We received funding from the Ministry of Resource and Innovation. We also received funding from SDTC, which is a federal government group. And in total, it was about $5 million. So it was a significant amount of money that really took this Ontario-based technology that was developed at an Ontario university and allowed us to complete that product development cycle to really start selling to the world. Veolia was absolutely incredible as a partner for us, and they took us right through the entire commercialization phase. It was a big company, so we were manufacturing in the United Kingdom, we were doing engineering in France, we were doing analysis and all over the world. It was a very exciting time. But in 2016, due to some big changes at Veolia, big changes in the world's banking sector and everything like that, there was an opportunity to take this company and bring it, repatriate it back to Canada. And that's what we did. So now, we're a privately held, Canadian-owned company. We're very excited, Canadian owners. And we did things like that manufacturing that was in the UK. We brought that back, not just to Canada, not just to Ontario, but it's in Kingston. So we're very pleased to be working with a manufacturing partner here in Kingston for our instruments here. The supply chain for the cartridges that we'll talk about in a little bit, the very important substrate, which is the magic ingredient that's for all of our patents, that's manufactured right here in Kingston as well at Queen's University. And the supply chain stretches across the GTA as well. So we're very excited that we're not only now a Canadian company, but we're manufacturing in Canada, and we're selling. This is our test cartridge, and we call this a CCA, and a combined coliform test. And the reason it's called a CCA is because as engineers, we're very bad at doing marketing. So that's why it's called something as terrible as a CCA. But this is where all the magic happens. This is where all of our patents are. This is what makes this test completely unique from the other tests that are out there. As I said, all the other tests are totally manual. Microbiology is complicated. It is a complicated science. If you get microbiologists in a room together, they will argue over what an E. coli is. They will argue about the very basic things because it's science and it is complicated. What our goal is here is to take the complicated science of microbiology, make it so simple that you or I or anyone else can run a microbiology test that's the same quality and the same standards as a very high quality lab,
Fantastic.
and get the same results and have the same protection of our water systems and the same protection of human health. So this is a regular plastic bottle. It's molded, and what we have in here is we have a rubber silicone element that's in the bottom. And that is very, very important to us, because what this does is it collects all of the elements that we're looking for, and it collects them in this one little spot. So instead of them all being floating throughout this entire water sample, they're collected in this one place, and all of a sudden we can automate the detection of them because they're in that one spot.
Okay.
So what's interesting, I find, as an engineer, as the development of this could only happen in a research institution, because they gathered a bunch of people together, and there was engineers, from mechanical engineers and civil engineers and environmental scientists and people from all sorts of disciplines, chemists, and they got together and said, this is what we need to do. The science behind this started with detecting oil in lakes. And the reason they could detect the oil is they looked for an enzyme in lake trout. And the professor of chemistry that was doing this analysis for these enzymes to find oil in lake trout, that is the basics of the chemistry that is taking place in this E. coli test. We've already put the sample in here. All the chemistry, everything that's required is ready to go. And all I need to do is tell the system here that we would like to run a test.
Okay.
All right, so the system does everything. All I've done, I've added a test there, and now it says I'm waiting for that. So if you could do the honors, help me open the lid here.
All right.
There you go. And it's looking for the test in the top left, so I'm going to ask you to pop that into the top left quadrant there.
Okay.
Close the lid. And now we can walk away. Our job is done. That is it. The water levels here in Kingston, from what I understand, are unprecedented.
Absolutely.
They have simply never been that high.
Yeah.
And the various contaminants that would leach out of the soil. The Walkerton disaster was caused by contaminants washing into wells after tremendous rainfalls.
Yeah.
So absolutely, anyone that's on a well system, you do have to be very, very diligent and vigilant when it comes to your water and making sure that it's continuously safe. We take our water for granted here in
Yes,
Canada.
that's right.
We
do.
absolutely do.
Yeah.
We have such a wealth of resources. In Ontario, we're blessed. We look at Lake Ontario and say, oh, we got tons of water. But that is raw water. The effort that goes into creating safe drinking water is absolutely tremendous. The technology that's required, the innovation that's required, the engineering that's required. We have to absolutely always be vigilant and make sure our water is safe.
All right, well, thank you very much, and thank you for joining in. We're absolutely delighted to bring this research and innovation into your homes. And thank you for joining us on Conversations with Sophie. We hope you'll have a good day.